Hi, I'm Rob, and I'd like to welcome you to this video in the AI Engineering Hands-On playlist on the Cumulus Cycles channel. In the last two videos in the playlist, we built a RAG pipeline, and it was powerful. You asked it a question, it retrieved the right context, and the model answered. But here's the limitation with RAG. We were always in control. We decided when to retrieve, and what to send to the model. The model just answered. In this video, that changes because we're going to give that model a set of tools, and we'll let it decide what to do, which tool to call, what arguments to pass, whether to call one tool or three, whether to search a document, hit a structured lookup, or just answer directly. The model figures that out, not us. And that's the shift from RAG to agents. RAG retrieves, agents decide. So in this video, we're going to build an AI agent from scratch with function calling, the agent loop, RAG as a tool, and a Streamlit app with a live trace showing every decision the model makes. But before we get into that app code, we'll take a look at the project README, then a few notebooks to get us ready. So as previously mentioned, the last two videos in the playlist focused on RAG, whereas now we're moving to agents. This table gives a quick comparison between the prior videos and this one. Feel free to pause and check it out, but I'm going to continue to scroll down to get to the prereq section so we can get started. So the prereq section is pretty small, but it does point out that I'm using UV as my package manager, but feel free to use whichever tool you're familiar with, and it mentions you'll need an OpenAI API key. So if you don't have one yet, head on over to platform.openai.com/API-keys, sign up, then follow the docs to create your key. You'll need to put it in the .env file in the demo folder, as we'll see shortly. The rest of the README has setup steps for the notebooks and the Streamlit app, but since we're going to build this from scratch, I'll create a new project in Cursor so we can get started. Okay, as mentioned before, we're going to create a few notebooks before we dive into the Streamlit app. So I'll create a notebooks directory and change into it. Create my UV virtual environment and activate it. Then create a requirements.txt file for the libraries we'll need for the notebooks, which we see here. Now I'll install the libraries in the virtual environment. Then register the virtual environment as a Jupyter kernel so it appears in the kernel selector when we launch Jupyter Lab. Now I'll create a .env file so we can add our OpenAI API key. So go ahead and paste yours here. And now we can launch Jupyter Lab. So I'll go ahead and create a new notebook and select our agent's kernel and rename the notebook real quick. And I just want to point out that even though I've provided you with 3 notebooks in the repo, I'll just create one notebook in the demo with all the content. So we don't have to create new files and switch between notebooks. So when you only see me working with one notebook here, just remember that the content is split up into 3 notebooks for you in the repo. Okay, now in the first cell, I'll add our imports, then call load.env to load the OpenAI API key from the .env file, create an instance of an OpenAI client, and set the model to GPT-4o Mini. Now, the first concept we're going to cover is function calling, which is how the model uses tools we'll provide it. So in the prior RAG videos, we always told the model exactly what context to use. In this demo, the model will decide for itself. We'll give it the tools and it will decide which to call with what arguments based on the user's question. And that decision is the function calling aspect of the agent implementation. Now, before we can give the agent the tools, we need to create them. And I want to be able to share these tools across the notebooks as well as the Streamlit app. So I'm going to create a tools folder in the root of the project, then add a tools Python file that we'll import. Now I'll create an init.py file to mark the directory as a package so it can be imported as a module. Then add the names of the tool modules we'll create. Now I'm going to make this a little bigger so hopefully it shows better on the video. And add a comment so we know what we're building. So as mentioned, this file is going to be a shared tool definition for the agent's demos. The notebooks will import it, as will the Streamlit app. So when we create our tools, each one will have two parts: a Python function that does the actual work, and an OpenAI tool schema, which is a dictionary, that describes the tool to the model so it knows when and how to call it. First, we're going to import path because we need to load a markdown file which has information on the company we're creating the application for. So I'm going to go out and grab that document real quick and put it in a data folder. And if we look in the data folder real quick, we see our markdown file. Now we'll go ahead and load the file and store it as a document. And now we can create our first tool, which will be to get product info. So as we see here, this tool will return a short description of a named insurance product by scanning the company document we just loaded. And if the product isn't found, the model will indicate that. So here we'll define our products, like AI infrastructure and operations protection, with a definition of the coverage. And next we'll define the get products info function, which takes a product name and returns its short description. So first we'll define a key from the product name that was passed in. Then if the key is found in the products, we'll return it. If there isn't an exact match on the product, we'll fall back to a substring search so the model can pass a partial name and still get a hit. Else we'll return a message saying that the product wasn't found. Now we'll create the second tool to get the pricing estimate, which will return a rough annual premium estimate based on the coverage type and the company size. And for this demo, we're just going to use a simple lookup table, so we don't need to create an additional API to access an external data source. So here we'll define the base premiums and some coverage multipliers for the specific coverage types. Then the get pricing estimate function, which will take a coverage type and the company size. So we'll create a size key from the company size passed in. Then we'll check to see if the size key is in the base premiums. And if it is, we'll go ahead and get the base premium and then the multiplier. We'll add variables for the low, mid, and high ranges. Then return the estimated annual premium for the coverage type, the company size with the high and low range, as well as the min point. And now we'll create our third tool to check eligibility, which will return whether a given industry is in the company's target market. So we'll define the eligible industries, and then the check eligibility function, which will take an industry. First, we'll get the key from the industry, then we'll traverse the eligible industries, and if we get a hit, we'll return a message saying that the industry is within the company's target market. Else we'll return a message saying that the industry is not in the target market segment. Okay, now we need to create the tool schemas, which are passed directly as the tools parameter to the chat completions create API. So the tools will have a type of function. This particular tool's function name is getProductInfo, and here's a description for using the function. The parameters passed to the function is an object with properties of product name, which is a string, and we provide a description of that property. And as we see here, for this tool, product name is required. The next tool will be the getPricingEstimate function. Again, we provide a description. And the parameters for this function have two properties, coverage type and company size, which are both required. And our third schema is for the check eligibility function, which takes a required industry parameter. So those are our tool schemas. And next we'll add our tool functions, which maps the tool name to the function. Now let's go ahead and save this file and jump back into our notebook, and then we'll import the tool schemas and functions from tools. Now we'll print the tool schemas. And the tool functions. Now we'll create our first question, which is about product details. So the model should choose the Get Product Info tool. Now we'll build the message that we're going to pass to the model, as well as the tool schema via the tools parameter. So the model will decide whether to answer directly or call the tool. So here we see we're passing the model, the messages with the question embedded, the tool schemas, and we're setting tool choice to auto, which means that the model could decide whether to call the tool or not. Then when we execute the cell, we'll print the stop reason, which is in the response's finish reason property, as well as the full response message. Now, stop reasons in AI agents are fields returned in API responses that explain why the model stopped generating tokens. They indicate whether the model finished naturally, requested a tool, which is a function, or reached a limit, which is crucial for controlling the loop-based agent workflows. So let's go ahead and run this cell. And we see the stop reason was for tool calls, and the full response message is the chat completions message. And we see the tool calls was for a function named getProductInfo with an argument of product name being agentic AI liability insurance, which is what we asked in the question. Now, when the finish reason is tool calls, the model's not done yet. It's asking us to run a function and report back. So let's look at exactly what it asked for. So the model's message contains a tools call list, with each item in the list having an ID, a type, a function name, and the arguments, which we see above. So we'll go ahead and print those properties and then parse the arguments from JSON into a Python dictionary so we can unpack them when calling the actual function. So let's run this cell, and we see the details of the tool that the agent wants to call. Now we'll run the Python function the model requested and add the result to the message history with the role tool. Then we can call the API again so the model can read the result and write the final answer. So here we'll look up the Python function by name and then call it, passing the arguments, and print the result. Then we'll update the message history with the original system and user messages, the model's message that contained the tool call, and a new tool role message with the result. So to the messages, we'll append the response message, which is the tool call, as well as the role, the tool call ID, and the content. Now we'll make the second API call, since the model now has the tool result and can write a final answer. And we'll run the cell. And we see the stop reason is stop, indicating the model has finished generating its final answer, and we see the final answer. Now, it's key to point out that the routing is done by the LLM. We don't write any if instructions like if question contains price, then call this function. So let's ask a few different questions and watch the model pick a different tool each time. So we're going to define a single tool called demo function that takes the user's question. We'll build the message, setting the role as system and the content, then add a user role, setting the content to the question. So remember, we're making two calls to the chat completions API. The first one is to get the tool from the tool schemas. Then we'll get the tool called, the arguments, and the results by calling the function in the tools function and passing the args. Then in the second call, we'll append the response messages to the messages, as well as a tool role with the tool call ID and the result as the content, setting the tools equal to the tool schemas, and then print the content from the result. So let's go ahead and load this function. And now we'll call the single tool call demo with 3 different questions and check the response to see which tool the model chose for the specific question. So let's go ahead and run the cell. And for the first question, we see that the tool called getProductInfo, because the question was asking for coverage on a specific product. For the second question, the tool was the getPricingEstimate, because the question referenced insurance costs for a startup. And for the third question, the model called the check eligibility tool, because the question was about getting coverage for a specific industry. So, as we mentioned earlier, not every question requires a tool. It's up to the model to decide whether it needs to call a tool or can answer the question on its own. So here we'll create a general question asking, what is AI agent ensure? We'll set the system roles content as well as the user roles content equal to the general question, then call chat completions, passing the tool schemas again, and then print the stop reason and the answer. So let's go ahead and run this. Oh, and so much for my copy pasting ability, which to be honest is better than my typing, which is why I'm doing this. We'll go ahead and fix our messages, then run the cell again. And we see the stop reason is stopped and that the model didn't call a tool. It was able to answer the question directly. Now, up until this point in the demo, we looked at a manual cycle where we send a message, the model requests a tool, we run it, feed the result back to the model, and the model answers. That works okay for one tool call, but for a real agent, we may need to call multiple tools in sequence before it can answer. So now we're going to look at wrapping those calls into the agent loop cycle that keeps running until the model says it's done by returning a finish reason of stop. And that whole loop is the agent. So let's go ahead and work on that implementation. We'll start by defining a system prompt for the agent. Then we'll define the run agent function, which takes the user question and the maximum number of iterations. This will run the agent loop for a single question. The loop will call the model with the current message history in a tool schema. If the model returns tool calls, it will execute each one, appending the result to the message history, and it will repeat the loop until the finish reason is stop. And then it will return the model's final answer. So we'll define the messages for the system and user roles. Then for each iteration, we'll call chat completions, passing the model messages, tool schemas, and telling the agent to choose for itself. We'll get the choice and the finish reason. Then we'll append the model's message to the history so the conversation stays coherent. And if the finish reason is stop, we'll return the message's content. Else, if the finish reason is tool calls, for each tool call in tool calls, we'll get the function name and arguments, then call the function in the tool functions, passing the args, and then appending the result and the tool call ID to the tool role in the messages, as we saw before. And then return our final message. So let's go ahead and load this function. And now we'll test out a single call. And we see here there was one iteration. The finish reason was tool calls, and the tool called was get product info. Now let's run a test with two tool calls in sequence because we're passing two questions. And we see the finish reason was tool calls. The first tool called was check eligibility, and the second was get pricing estimate. Now, we know it's important to always append the model's message to the history to keep the conversation relevant. So let's create a new function called run agent with history, which will show us every step the agent took. So the user's question, the model's tool requests, the tool results, and the final answer. So here we'll call the run agent with history function, passing it the queries, saving the history and the answer, and then printing the result. So let's go ahead and load and run the cell. And here we see the full message history, starting with the system message, the user message, the assistant tool calls, which is check eligibility, the tool result, and then the final answer. Now, scrolling back up to the run agent function, there's one parameter that's passed in that I didn't really focus on that we're going to take a look at now, and that's max iterations. We did say that we would loop through the max iterations, calling the chat completions API and finishing the agent loop, but let's scroll down and call the run agent function again, passing max iterations of 1. And this is a safety guard. So we set max iterations to 1 to force the loop to stop before the model finishes. So in production, you might want to set this to something like 10, which is high enough to handle complex tasks, but low enough to prevent runaway loops. So let's just run this cell and see the result. And here we see one iteration with a tool call to get product info, and the result is that the agent stopped after one iteration without a final answer. Now, so far in this demo, we gave the agent 3 structured tools: product info, pricing, and eligibility. Now we're going to add a 4th, search docs. And this is going to be the RAG pipeline from the prior videos in the playlist. And we're going to wrap it as a tool. RAG becomes one tool among many. The agent decides when to search the document, when to call a structured tool, and when to do both. We don't hard code that logic, the model reasons about it. So some of the code that we're going to write here is going to look familiar if you watched the prior 2 videos in the playlist. Here we're going to import ChromaDB, set our embedding model and the top K to 8. We'll define a system prompt for the RAG tool and go ahead and load this cell. Now we're going to go ahead and build a RAG index, and this is the same pipeline that we used in the prior videos. So we're going to load the document, chunk by sentences, embed with OpenAI, and store the results in a ChromaDB vector store. And we see we loaded 34 chunks from the AI agent ensure markdown file in the data folder. Now we're going to wrap RAG as a tool. So we'll write a Python function that takes a query string, embeds it, retrieves the top K chunks, and then returns them as a single string. Then we'll add an OpenAI schema so the model knows the tool exists and when to use it. So here we're getting our query embeddings and the vectors, and the results of calling query on the ChromaDB collection, passing the vectors and the top K. Now we'll add a search docs schema, specifying the function name of search docs, the description of when to use it, and the parameters with a property of query that's required. Now we'll extend the tool list and the dispatch dictionary from the tools Python file with the new RAG tool, and load the function. Now we'll define a run agent RAG function, which takes the user question and the max iterations, builds the messages for the system and user roles, traverses through the max iterations, calls the chat completions API, passing the tools, gets the response choice and appends that to the messages. If the finish reason is stop, we'll return the message content. Else if it's tool calls, we'll process the tool calls, finally appending the tool role, the tool call ID, and the content to the messages, and then returning the final answer. So let's go ahead and load this function. And now we'll ask a RAG only question and check the answer. And it looks like I forgot to define all schema. So let's check that out. Okay, I see what I did. In the search docs function, my tabbing for the search docs schema and the code that's highlighted was under the function definition. So let's go ahead and reload this. We'll rerun this function definition again, and we'll go ahead and test it out. And that looks better. So we see the finish reason was tool calls, the tool was search docs, we have the result and the response, and then the second iteration, the finish reason is stop, and we have the final answer. So now the agent is using RAG as a tool. Now let's go ahead and run a test with a structured tool question. So this is a pricing question. So the model should use the get pricing estimate tool rather than searching the document using the RAG tool. And here we see the proper tool call. And now we're going to run a test that triggers both the RAG and the structured tools. So this is the key demo for this notebook. The question asks for both background information, which will be retrieved using the RAG tool, and a price, which is using the structured tool, which is the get pricing estimate function. So let's go ahead and test it. and we see the first iteration finished with tool calls. The tool was search docs, and then the second tool was the get pricing estimate, which triggered the finish reason of stop, and then we see the final answer. This from the RAG call, and this from the get pricing estimate tool call. So that wraps up the demo notebook portion of the video, and now it's time to build the Streamlit app. So I'll jump back into Cursor, and in the root of the project folder, I'll make an app directory and change into it, then create a virtual environment for the app, activate it, and make a requirements.txt file, and add the libraries, and a .env file with our OpenAI API key. Then I'll install the requirements, then create the Streamlit app file. So we'll start by adding our imports, then the path to the shared tools, which we created in the tools folder. We'll load the OpenAI API key from the .env file, set the model and the embedding model, the top K, and the data path to the AI agent ensured markdown file. Now I'll add a system prompt, then a function to build the RAG index once per session, which is controlled by the Streamlit cache resource decorator. So here I'll create an instance of an OpenAI client, load the markdown document, get the raw content, then create the chunks using sentence chunking. Then we'll call create on the OpenAI client embeddings module, setting the model to the embedding model and the input to the chunks, then take the response and create the embeddings. Here we'll get an instance of ChromaDB and create a collection, then add to the collection the IDs, the embeddings, and the document chunks. Then return the collection, the OpenAI client, and the chunks. Now we'll create a make search docs function for the search docs tool, which takes the ChromaDB collection and the OpenAI client, and inside of this, we'll define the search docs function, which takes the query and creates the embeddings from the query and the query vectors by calling query on the collection, setting query embeddings equal to the vectors, and setting the top K. Then we'll get the results and return back to the make search docs function so that they can be returned to the caller. Here we'll define the search docs schema, which is a function. The name is search docs. We'll give it a description, and the parameter has a property of query, which is required. Now we'll define the agent loop. So we have a run agent function that takes the user question, the schemas, all the functions, then OpenAI client, and max iterations. So like we said, this function will run the agent loop and return the final answer and the trace of the agent's processing, where trace is going to be a list of dictionaries describing each tool call. So here we'll create our messages and a list to hold the trace. Then for each iteration, we'll call the chat completions create API, passing the model, the messages, all schemas to the tools, and setting tool choice to auto. And from the response, we'll get the choice and then append the choice message to the messages. And if the choice's finish reason is stop, we'll return the message content and the trace. And if the finish reason is tool calls, for each tool call in tool calls, we'll get the function name, the arguments, call the function, passing the arguments, and get the result. Then we'll append to the trace a tool, which will be the function name, with the function arguments and the result. And of course, append to the messages, the tool role with the tool call ID and the content, and return our response. And now we'll write the code for the Streamlit UI. Here, we'll set the page config, passing a page title and a page icon. We'll set a title on the page and a caption. Then we'll build the RAG index and wire up the tools. So we'll create a search docs function variable, setting it equal to make search docs, passing the ChromaDB collection and the OpenAI client. We'll set all schemas equal to the tool schemas and the search docs schema, and then populate all functions. We'll add a sidebar that'll show us the number of chunks and available tools. then create a question variable, which will be the contents of a Streamlit text input field, and then we'll listen for the click of the ask button. So here we'll populate the answer and the trace variables by calling run agent, passing the question, all schemas, all functions, and the OpenAI client. Then we'll display the answer on the page and then show the trace. So with that, our app is done. So let's jump back into the terminal and launch the app. So here we see we had 34 chunks indexed and the available tools, and we'll ask a question. And we see the answer, and if we scroll down, we see the tool call. Now let's scroll back up and ask 2 questions. Can you explain AI agent ensures underwriting philosophy and tell me? And also, what model and data security insurance would cost for a startup? So let's go ahead and ask this question. And here we see the underwriting philosophy response and the cost of model and data security insurance for a startup response. And if we look at the agent trace, we see 2 tools were called. First, search docs for the underwriting philosophy and get pricing estimate for the cost of insurance for a startup. So that concludes this video on building an AI agent from scratch. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.